Throughout human history, we have repeatedly asked one of the most profound questions imaginable: how long will humanity endure? Predictions about our future have ranged from the philosophical to the mathematical, from the apocalyptic to the cautiously scientific. And agora, uma nova proposta surgiu, menos a afirmação de que, em exatos 314 anos, a espécie humana estaria extinta. This claim comes from a recently published demographic study that, using statistical tools and population modeling, arrived at a numerical prediction bold enough to attract worldwide attention. But where does that number come from? How reliable is it? And what does it truly mean? In this documentary-style narration, we explore the foundations of this study, analyze its assumptions, and contrast its conclusions with historical, scientific, and demographic knowledge. More than anything, we aim to show how scientific projections should be interpreted not as definitive fates, but as scenarios shaped by assumptions that must be examined critically. The article that inspired this debate bears a title as striking as its conclusion: Human Extinction from a Probabilistic Demographic Perspective. From the outset, the title suggests a mathematical approach to a deeply human question. The authors employ population projection methods, most notably the Hamilton-Perron HP model, a statistical framework designed to estimate future population sizes based on current demographic counts. Population projections typically incorporate three core components: fertility, mortality, migration. Using these variables, demographers attempt to forecast how populations will evolve over time. However, the researchers behind this study chose to focus heavily on a single metric, the child-to-adult ratio. Their reasoning was that this ratio serves as a condensed indicator of long-term demographic sustainability. If fewer children are being born relative to the adult population, they argue, the long-term trend may point toward population decline and ultimately, extinction. The authors examined the behavior of this ratio over a 5-year window, from 2019 to 2024. During that period, they documented a 7.5% decline. Then, they made a bold extrapolation. If this decreasing trend continued indefinitely, the population would eventually approach zero. Using this continuation assumption, they concluded that humanity would vanish in approximately 314 years. It is a conclusion that gained attention precisely because of how concrete it sounds. But as we shall see, concreteness in numbers does not automatically imply robustness in method. The child-to-adult ratio compares the number of children to the number of adults in the population. A lower ratio signals fewer children being born, which in turn suggests lower future reproduction. This metric can offer valuable insight into demographic health. However, basing a long-term global projection solely on this ratio and over such a short observational window presents a series of serious problems. The dataset is extremely short. The years 2019 to 2024 coincide almost exactly with the global COVID-19 pandemic. Pandemics cause temporary but significant distortions in many demographic indicators. Fertility rates tend to fall as uncertainty rises. Mortality rates spike irregularly. Migration flows slow dramatically. Economic instability affects reproductive decisions. Thus, a trend observed during these years may reflect exceptional circumstances, rather than long-term behavior. B. Demographic trends are not linear. Human populations do not decline or grow in straight lines. They respond to economic cycles, technological innovations, social policies, cultural changes, environmental pressures. A simple linear continuation of a short-term decline ignores the dynamic feedback loops that have shaped demographic history for centuries. C. The ratio ignores other essential variables. A meaningful demographic projection must incorporate age structures, migration flows, life expectancy changes, fertility by cohort, urbanization patterns, economic evolution. Reducing population dynamics to a single ratio strips the system of its complexity and produces unstable conclusions. Extrapolation, the process of extending present trends into the future, can be valuable when used responsibly, but it becomes dangerous when the dataset is short, the system is complex, the trend is unstable, or the timeline extends too far into the future. Projecting 5 years of data 3 centuries forward is not just ambitious, it is an oversimplification of reality. Demographic models dramatically diverge when projected long-term. A slight adjustment in the decline rate, say 7.5% instead of 6%, can produce population outcomes that differ by billions of people over 300 years. A scientifically rigorous model would present a range of possibilities, not a single deterministic endpoint. Human population dynamics over the past 200 years illustrate how unpredictable demographic transitions can be. The demographic transition model shows how nations evolve from high birth and death rates to lower ones as healthcare, education, and economic conditions improve. But this process does not unfold uniformly. Some countries reverse fertility declines with incentives. Others stabilize at low fertility but sustain population through migration. Some experience fertility rebounds after periods of social or economic instability. The world's demographic history is characterized more by cycles, adjustments, and corrections than by uninterrupted, linear decline. In other words, trends change, Assumptions break. Human behavior adapts. Demography does not exist in isolation. Any long-term projection must consider the transforming forces of human civilization. Economic structures. Prosperous societies tend to have fewer children, but they also have stronger safety nets, reproductive health systems, and policies that can shape future fertility trends. B. Public policy. Governments worldwide already implement parental leave models, childcare support, financial incentives for families, immigration programs. These interventions can significantly alter demographic trajectories. C. Technology. Technological revolutions shape reproduction, longevity and labor, fertility treatments, longevity research, robotics and AI resource management, innovations. Future societies may sustain stable populations with far fewer births due to increases in automation and productivity. D. Culture. Family patterns change with urbanization, education, gender equality, lifestyle preferences. Cultural evolution is unpredictable across centuries. The years 2019 to 2024 will likely be remembered as one of the most unstable demographic periods of the century. Pandemics altered demographic data in ways that do not reflect the natural equilibrium of societies. Fertility dropped in many regions due to economic stress, social uncertainty, health fears, reduced access to reproductive services. Mortality spiked in ways that distorted age structures and skewed ratios. To take these 5 years as a baseline trend for the next 3 centuries is to commit a classical statistical error. Interpreting noise as signal. Science advances when we question assumptions, not when we accept numbers at face value. A projection like 314 years to extinction may look precise, but precision can disguise fragility. A good scientific question is, which assumptions are necessary for this result to hold? In this case, the answer is the assumption that a pandemic-influenced 5-year decline will repeat identically for 31 decades. This is not a realistic assumption, and that is exactly why the conclusion, while mathematically correct within the model, is scientifically weak when interpreted as a prediction. Long-term projections in demography usually consider multiple scenarios. Scenario 1, decline without extinction. Population shrinks slowly over centuries but stabilizes at a lower number. This is widely considered plausible. Scenario 2, stabilization. Fertility rates balance slightly above or below replacement level through policy and adaptation. Scenario 3, migration-driven balance. Regions with declining fertility absorb populations from younger regions. Scenario 4, collapse. Rare requires catastrophic multi-factor global failure, not demographic decline alone. Scenario 5, extinction. Extremely unlikely through demography alone. Demographic decline is not enough to cause extinction unless compounded by environmental, technological, or existential threats. None of these standard scenarios align with the deterministic 314 years result. Despite its limitations, the study serves a valuable purpose. It ignites discussion about population sustainability and long-term human planning. It reminds us to monitor fertility trends, aging populations, socioeconomic pressures, climate-driven migration, global inequalities. But it does not demonstrate that extinction is imminent or calculable with simple extrapolation. Humanity's future is not governed by a single ratio, a 5-year dataset, or a deterministic equation. It is shaped by social decisions, technological breakthroughs, economic resilience, and the extraordinary human ability to adapt. The suggestion of extinction in exactly 314 years is not a prophecy. It is a mathematical artifact of an oversimplified model. The true lesson is clear. Question assumptions. Understand context. Treat predictions as scenarios, not destinies. Humanity has survived plagues, wars, collapses, and evoluções tecnológicas. We are not invulnerable, but neither are we passively bound to a statistical projection derived from an unstable moment in history. The future is not written, it is built.